Alright class, so today we are taking notes on limiting reactants, and limiting reactants is basically a branch of stoichiometry. It has the mole-to-mole ratio still, so in that sense we are doing long problems, mass-to-mass problems. Limiting reactants are fairly logical. They take the most time just because we have to do 4 different fence and rail problems and do a little bit of just subtraction in between. So anyways, we'll get started on it kind of quickly, but the notes on this one will take a little bit of time just because it takes so long to do one of these. So the first thing we have to do is balance the equation. So I'm just going to rewrite NH3 plus oxygen yields nitrogen monoxide plus water. And as we balance this, I'll just start with N. So we've got an N on the left and N on the right, so that's good. 3 H's on the left, 2 on the right, so we need least common multiple. So I'm going to put a 2 in front of ammonia and a 3 in front of water. Because I put a 2, now I might have 2 nitrogens, so I need to put a 2 in front of NO. And then lastly, we basically have 2 O's on the right and 3 O's, that's 5 O's, so I'm going to put 2.5 in front of oxygen. You can leave it like this. Back when we did balancing equations, they have to be whole numbers. Stoichiometry, all we're concerned about is the ratio. So a 2 to 2.5 ratio is the same as a 4 to 5 ratio. So you can leave it as halves if you like to with stoichiometry. I'm going to do it just because it's a little bit different, and I don't want to have to erase everything because it's kind of a pain. So the next thing that's kind of different on this than we did last week is last week you were given the mass of one of your reactants. Okay, so what we assumed was the other reactant, what was the excess reactant. There was plenty of that. And the reactant we gave you was what is known as the limiting reactant. So the limiting reactant is what limits how much product can form. So really the limiting reactant determines how much stuff we can make, not the excess. So notice number 2 says we're going to identify which of the reactants is limiting and which is excess. And we do that by doing 2 fence and rail problems. And we're going to solve for one of our products. So it doesn't matter whether we solve for the NO or the water. We're going to solve for one of them, because at the end of the problem we're going to need to know both of them anyways. So I am just going to start with the first one just because NO happens to be first, but you can solve for water if you would like to. Okay, so we're going to do 2 fence and rail problems. First one, we're going to start with 15 grams of ammonia, and it's going to be a mass-to-mass problem. So we are going to have 3 different parts of our fence, or really 4 parts, but 3 vertical rails, I guess, 3 fence posts, 4 sections. All right, so grams of NH3 is on top, so I'm going to put grams of NH3 on bottom. My units guide me. And I'm going to have moles of NH3 on top. And if there are moles and grams in the same fence post, that's known as the molar mass. And when we have molar mass, it's always 1 mole. And then my grams is going to be 17. I'm just going to round these to whole numbers. On your homework, if you could put all the numbers in the periodic table, I would appreciate it. But for now, we're just going to round these. So nitrogen's 14, and each of our H's is 1, so it's about 17 grams. Okay, the next thing is, if I let my units guide me, I'm going to have moles of NH3 on the bottom. And we decided we're going to go to NO, so I'm going to put moles of NO on top. And this ratio is simply a 2 to 2 ratio. And then lastly, I want to change my moles of NO to grams of NO. Alright, so once again I have moles and grams in the same fence post. That's molar mass. If it's molar mass, a 1 goes in front of moles. And my mass of NO is basically 30, because nitrogen's 14 and oxygen's 16. And when I do that math, I believe we get about 26.47 grams of NO. Okay? So, same exact thing, except now we're going to start with 25 grams of oxygen. So again, we're starting with both of these reactants, both of their amounts, and going to the same product. So 25 grams of O2. And we have a 3 fence post problem again. Grams to moles to grams. So let my units guide me. I have grams of oxygen to moles of oxygen. It's molar mass. So I've got 1 mole, and it weighs 32 grams because each oxygen is 16, and it's O2. Next part is going to be moles of oxygen. And I'm going to change this to moles of NO. And if we look at that ratio, we have 2 to 2.5. If you balance this properly up top, it's going to be 4 to 5. So mathematically, you're going to get the same exact answer. And then lastly, we have moles of NO to grams of NO. And in this case, we have 30 grams again and 1 mole. So when we do this math, we find our answer is 18.75 grams of NO. Alright, so I mentioned earlier that the limiting reactant tells us how much product we can actually make. Okay? So, whichever one of these is the smaller amount is the correct amount. So maybe here in your notes you might say the first reactant produced 26.47 grams, and the second reactant produced 18.7 grams. So this is really how much we can make, is 18.75. So which was the reactant that gave me the smaller amount? It was oxygen. So under here on part C, oxygen is going to be our limiting reactant, and our excess is NH3. So when our reaction is done, we're going to have a little bit of NH3 left as well as the two things we are making. So in our reaction, we're making NO and water. At the end of our reaction, we're going to have some NO, we're going to have some water that we made, and there's going to be a little bit of NH3 left, but all of our oxygen will be completely gone. All right, so the next thing we do on a limiting reactant problem is starting with the smaller product, okay, or 18.75. So I'm just going to put this over here, 18.75 grams of NO. We're going to determine the mass of excess reactant that's required to react. Okay, so if we make 18.75 grams of NO, we want to kind of work backwards and find out how much of that NH3 we're actually going to use up. Okay, so again, it's going to be a 3 fence post problem at grams of NO. So on the bottom, I'm going to put grams of NO, and I can change grams into moles. And for every 1 mole, we have 30 grams of nitrogen monoxide. Next thing is I'm going to go moles of NO, 2 moles of NH3, because NH3 is my excess reactant. And I think this was a 2-to-2 ratio, if I remember correctly. All right, and lastly, I'm going to change moles back into grams. Apologize for my writing. So we have 1 mole equals 17 grams. All right, when we do this math, we find that we would need 10.63 grams of ammonia are required to make 18.75 grams of NO. All right, so next thing is the amount of excess left after the reaction. So we're going to subtract the amount of excess used from the amount of excess available. So if we go back to the top, we're going to find out how much NH3 we started with. And we started with 15 grams of NH3. So I'm just going to put 15 grams of NH3, because that's my excess. And I'm going to subtract what I needed. So I needed 10.63 grams of NH3. And when I do that math, I find that I have 4.37 grams of NH3 left over. Okay? So that is excess reactant. It did not all get used up, but we had more of it. Okay? So last thing, number 5. The amount of products from the reaction is determined by the limiting reactant. All right? And then we have last 2 questions. One of these answers we've already done. Okay? So I want to know the amount of each of the products I can make. The amount of NO that can be made by 15 grams of NH3 and 25 grams of oxygen, and the amount of oxygen that can be made from 15 grams of NH3 and 25 grams of oxygen. So notice at the beginning, we already solved this problem. Okay? So it was our smaller numbers, whichever 2 we came up here. So notice it was this 18.75 grams. So I don't have to redo that. I have already solved this one. So I'm just going to put 18.75 grams. All right, and put C above or something like that, but it's just at the top of your page. However, at the beginning, if you would have decided to go to water instead of NO, you would have the answer to the second problem. You'd do a stoichiometry problem to solve the first. Okay? So again, we need it's our limiting reactant. So we need to go back to kind of to the top and see which one was our limiting reactant again and how much we started with. So 15 grams of ammonia and 25 grams of oxygen. So I'm going to start with 25 grams of oxygen. How many grams of water I can make. So at grams of oxygen, so grams of oxygen on the bottom, we have moles of oxygen on top. So that's 1 and 32 grams. And then we have moles of oxygen. And now we're going to moles of water. And I believe that was, what was it, 3 to 2.5. All right. And then lastly, I'm going to change my moles of water into grams of water. And that's 1 mole equals about 18 grams. I think it's 18.0148. But regardless, my answer would be 16.88 grams of H2O. All right, so that is limiting reactants. It's no new things you're learning. It's just a bunch of the same thing done over and over and over again, which really gives you great practice so that you're really efficient at what we did last week. And then really there's only one other thing we're doing in stoichiometry, which will be the next thing we learn, which is percent yield. So that is it.